All right, let's get into it. Today, we're basically becoming cosmic detectives, because our case, well, it's one of the biggest, most mind-bending puzzles in all of modern science.
And this isn't just some small question. No, this is a mystery that shakes the very foundations of how we think the universe works. And believe it or not, it all boils down to one single, super important number.
Okay, so to get our heads around this, you just need to know one key thing. Our universe is expanding. It's getting bigger. And not only that, it's speeding up. The classic way to picture this is to think about a loaf of raisin bread baking in an oven. As that dough puffs up and expands, all the raisins inside it move farther and farther away from each other. That's kind of like what our galaxies are doing.
So, scientists have a name for this expansion speed. They call it the Hubble constant. You can think of it as the universe's speedometer. And getting an accurate reading on that speedometer, it's absolutely crucial for figuring out, well, the entire story of our cosmos, where it came from and where it's going.
So here's what we're going to cover. We'll look at the expanding universe, the two conflicting measurements, how this whole thing blew up into a crisis, who the suspects are, the search for new physics, and why this is still a big unsolved mystery. Okay, let's dive right in.
All right, so this is where we get to the scene of the crime, so to speak. See, astronomers have two main ways of clocking the universe's speed. But here's the problem. The numbers they're getting, they just don't match up.
Let me try an analogy here. Imagine you want to know how fast a car is going to be going when it crosses a finish line, right? You could figure this out in two totally different ways.
So you've got Team Early Universe. They're like the engineers who designed the car. They look at its specs from the very beginning, in this case, the faint glow left over from the Big Bang, and use the laws of physics to predict how fast the universe should be expanding today. Then you've got Team Late Universe. They're the ones with the radar gun at the finish line. They don't predict anything. They measure the speed directly by looking at things in the universe right now, using exploding stars called supernovas as their cosmic radar.
So what does Team Early Universe find? Using incredibly precise measurements of that Big Bang echo from the Planck satellite, they calculate a speed of about 67 kilometers per second.
But then, Team Late Universe, with their cosmic radar gun, the Hubble Space Telescope, points it at those exploding stars and gets a totally different number. They clock the universe's speed at about 73. Faster. And this is where it gets really serious. You see those little lines on the bars? Those are the error bars, the wiggle room for each measurement. And they don't overlap, not even close. In science, that's a huge red flag. When two really good measurements that are supposed to give you the same answer are this different, it means something is fundamentally wrong. Or maybe, just maybe, it means we're about to discover something brand new.
So, at first, most scientists figured, it's probably just a mistake. Someone's math is a little off, or a telescope needs recalibrating. It'll go away when we get better data. But the exact opposite happened.
Look at this. Back in the 2000s, the measurements were a bit fuzzy, there was some overlap, so you could imagine they might eventually agree. But then, as our instruments got insanely precise, like the Planck satellite for the early universe and the SHOES team for the late universe, the numbers didn't get closer. They got locked in. Each side became more and more certain of their number, and the gap between them just got bigger and bigger. It's undeniable now.
And this comment from a science fan online really nails it. The thinking has totally shifted. People have stopped blaming the measurements. The early universe folks get consistent results, and the late universe folks get consistent results. So maybe the problem isn't with the measurements at all. Maybe the problem is with our understanding of the universe.
Okay, so our cosmic detective story now has two main suspects for what's causing this whole mess. Is it just a mistake, or is there some physics we're missing entirely?
So suspect number one is systematic error. Basically the idea that someone messed up. Maybe one of the teams has a hidden flaw in their method, like a miscalibrated radar gun. But here's the thing, this suspect has a rock-solid alibi. Scientists have gone over this with a fine-tooth comb for years. Other teams, using different methods, have checked the results, and they keep getting the same numbers. So, it's looking really unlikely that it's just a simple mistake.
So, if it's not a mistake, if the clues are telling the truth, then that leaves us with a much more exciting possibility.
And this is suspect number two, new physics. This is the big one, folks. This is the idea that our fundamental rulebook for the universe, what scientists call the standard model of cosmology, is actually incomplete. What if the physics we use to connect the dots from the Big Bang to today is missing a chapter? What if there's a new particle, a new force, a new something out there that we have no idea about?
And this is where things get really fun, because this crisis has just thrown the doors wide open for creativity. Scientists are coming up with all sorts of wild, brilliant new ideas to try and explain what's going on.
I mean, just look at this list. It reads like the table of contents from a sci-fi novel, right? Phantom brain worlds, uber gravity. Let's just quickly touch on a couple of the leading theories.
Okay, so one of the big ideas is something called early dark energy. The theory goes like this. What if there was a brand new type of energy field that was around for just a little while after the Big Bang? It would have acted like a short-lived cosmic gas pedal, giving the expansion an extra kick before it just disappeared. That extra push in the beginning could be why the universe is moving faster today than the early universe team predicted.
And there's an even more radical idea, modified gravity. This one is pretty wild, because it suggests that maybe, just maybe, Einstein's theory of gravity isn't the whole story. What if gravity behaves just a little bit differently over these unimaginably vast cosmic distances? If that were true, well, we'd have to rethink everything.
And that's just the start. People are talking about decaying dark matter, or maybe some weird new particles like sterile neutrinos are messing with things. The honest truth is, right now, nobody knows which of these ideas, if any of them, is the right answer.
So, we've laid out all the clues, we've looked at the suspects, so where does that leave our investigation? Well, the case is still wide open. It's an unsolved mystery.
But you know what? That's not a bad thing at all. In science, a crisis like this is really just another word for opportunity. It's these moments, these cracks in our understanding that let the new light in. This is how we make huge leaps forward.
And I love this comment from another science fan. It's so true. This is exciting. The universe isn't just being difficult. It's handed us a clue. It's basically drawn a big red circle on the map and said, hey, look over here. There's something new to discover.
We don't have the answer. Not yet. But this whole puzzle feels like a message from the cosmos, doesn't it? A signpost that's pointing us toward a much deeper, more complete understanding of, well, of everything.
Well, thanks for coming along on this cosmic investigation. It's a huge topic, and if you want to go even deeper, check out the Deep Dive podcast episode that covers this whole thing. The link is right there in the description.